Hi guys, in the last parts of these videos, we learnt about the Gibbs free energy change during a reaction. So now let's tackle an exam style question. Which of the following combinations can never happen in a thermodynamically feasible reaction? And then we're given combinations of having positive or negative entropies and positive and negative enthalpies. So remember, the Gibbs free energy is given by the formula of enthalpy change, delta H, minus the temperature times by the entropy change, delta S. For a reaction to ever happen, you would need a negative delta G at some point. So if we're trying to rule that out, we need to find out what the conditions are to always have a positive delta G at any temperature. So if we want delta G to be positive, that means we also want the change in enthalpy, H, to be positive. And then because we're taking away the entropy, we want to have negative of a negative, which will then also give us a positive, and the reaction will never be possible to happen. So we're looking for positive enthalpy, which is either this one or this one, and then negative entropy, which is the top one. So now that we know the answer is A. And here's our 1 mark. The next question tells us that methanol can be formed in the following process. It then gives us a reaction between carbon dioxide and hydrogen gas to form the methanol and water. And it tells us the entropy change of the reaction is minus 49 kilojoules per mole, so it's exothermic. Use the following data to calculate the free energy change of this reaction at 200 degrees Celsius. And then we're given a table with all of the entropies of the species involved. When you're starting out here, it's a good idea to write down the formula for the quantity they're asking you to calculate. So if we write down the formula for the change in Gibbs free energy, it's given by the change in enthalpy minus the temperature times by the change in entropy of the system. In the question, we're directly given the change in enthalpy of the system and the temperature at which the reaction takes place. So the first value we need to calculate to be able to find the Gibbs free energy change is the change in entropy of the system. So if we want to find the change in entropy of the system, then we remember that the formula is given by the change in entropy, the standard change in entropy of the products.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.